But you can still kind of estimate. Right? Y equals 2x, y equals 2x plus 0. All right, that will go something like this. And x plus y equals 12. So just the two numbers add to equal 12. 6, or you can do the slope-intercept form, negative x plus 12. So if you graphed it, that's what it would look like, and the answers are still the same concept. It's where they intersect. So when we finish this problem, we should have the same thing we get from graphing, but just without the graphing. Where do they intersect? Okay. So it's good to know at the very end of this problem, you need to have a coordinate, x and y. Now there's two methods for non-graphing solving of systems, elimination and substitution. We'll do substitution today, elimination tomorrow, and the next day. All right, so substitution. Substitute just means to plug in. Okay. So if we have a y right here, this is the same exact y. If this y equals 2x, this y is also equal to 2x.
4x. I mean 3x.
So you can say, well, yeah, that's equal to 2x. Well, so is this one. That's equal to 2x. And then just solve it. See how there's only one variable. So we have, 3 times what equals 12. And then solve it. So, yeah, you know x is equal to 4. So x is 4. This is x comma y, right? So put the 4 with the x, which means this intersects. If we graphed it, it intersect at 4 comma something. Okay. Go ahead and plug it back in. I'm going to just take this top one and say, well, y equals 2x. If you plug 4 into here, because x is 4, y equals 2 times 4 equals 8, which means y is 8, which means if we graph this, it would intersect at 4 comma 8. I could give you this exact same question to graph, and you'll get the exact same answer. So don't forget that there's only one answer, no matter what method you use. Let's do a few others. The easier kind is when it's already y equals or x equals. You don't have to do any work in the beginning. You just start plugging it in and substituting. Okay. So like on number 2, a good one to do. Let's go to number 4. Again, this is a little bit easier because it's already an x equals or a y equals. Notice how we don't care that it's x equals. You might say, well, is x equals okay? Because everything else we do is y equals. Well, if you're graphing, yeah, absolutely y equals. Okay. If you're not graphing, it doesn't matter. Plug it in. So this x right here is 4y plus 1. So is this right here. So you can replace this x with a 4y plus 1. And since there's a coefficient here, use parentheses. So plug that in right here. Face forward. Put that down. Face forward. Face forward. Put it down. So we have 2, 4y plus 1, and then go back, don't forget, we have minus 3y equals 12. So we didn't have to do any really work. It was already an x equals or an y equals, but we still have to do the solving here is a few more steps than what we're used to. Okay. So we have 2 times 4, 2 times 3, 1. Stay focused. Bring down everything else. We have 8y minus 3y. It's 5y. Bring down everything else. 2, make that a plus. Bring down that equals 12. Notice how I did not add 3y because these are on the same side. On the same side, you just combine them. Don't add 3y, you get 11y instead of 5y. And from here, you can probably finish it. And 5 times what is 10? Now you notice here is that when we finish this side, we found y. Make sure you put it in the right place. Y is on this is the second one. Okay. Take the equation that we started with and then y is 2, so plug it in. 4 times 2 plus 1. So we have 9. All this work is necessary. This is the final answer, though. It's just where they intersect. If you graph it. We're doing all the work. You can see the benefits of this is that the numbers are really big. Like what if the y-intercept was 175? Not something you could really graph. What if the slope was a decimal? Not something you can really graph. But this method, it doesn't matter at all. So there's really 2 parts, or 3 parts. There's a part where you have to plug it in, then you have to solve one equation, and then you have to plug that answer into the other one. So 3 steps. That's what it'll look like on your paper for each one. I think I have an example of the homework. Yeah. Yeah, so when you're finished, it should look something like this. All your work will look like this. Okay, you can see how I'm plugging it back in. It's kind of that 2-column format. Solve it, plug it back in, get an answer, just like that. Okay. So use the same format. It works every time. Now these are kind of the easier kind, as I mentioned. They're already x equals or y equals. Let's look at when they're not. So back to here. Let's go over to this column, 7. Alright. So this will require a little bit of work before we plug anything in, because you can't plug it in until you have an x equals or y equals. So looking at both equations, which one would be easier to solve for x or y? Bottom one and solve for x. So gotta do just a little bit of work. So x equals 7 minus 2y. And now you can do the same thing we just did on number 4. You got to have an x equals or y equals to make this work. All right. At x is the same as this one. Make sure when you plug it in, since there's a coefficient, use parentheses. So we'll have negative 2x times 7 minus 2y, and then plus 3y and equals 14. Plus 3y. Unfortunately, if you miss one little negative anywhere, it does make the whole answer incorrect. There were some of the answers, I don't know if you saw when I put the answers up there, that were fractions. So, and all the answers on the columns on the paper, so you know if you got it right or wrong. All right. Four y and 3y. Remember, don't subtract 3y, don't subtract 4y, they're on the same side. And just bring down everything else. And I'll let you finish that. I just wanted to show you the beginning on how the only thing new here was right here. Had to get it equal to x or y, just whatever's easier. Technically, you could solve any of these for x or y, and it'll work. It's just, if there's an easier way, let's do that way. Okay, next, last one. Let's see here. Any requests from the second column here? Ten. Okay, right here. Which of these is easier to solve for a single variable? Okay, bottom is, well, I don't know, this one is basically the exact same as 7. This one we had to subtract 2y on both sides. This one we're going to add 2y on both sides. So, yeah, nothing really different about this one. So we have x equals 2y plus 2. And then that x is what we can plug in right here. Minus 3y equals negative 11. Put that in the last one too. All right. Rest of you guys know, just going to be routine. If at any point you have two different variables, that means something's wrong. You should only have one variable as you're solving. 10 minus 3, 7. Bring down everything else. Okay. That's a negative. Negative. Subtract 10. Negative 11 minus 10 is negative 21. Yeah. So y equals, y equals negative 3. Just remember, you're not finished once you finish. This is not a finished problem. All we did is found out, well, one of them is -3, the y. You still have to plug that back in and finish it up. Okay, that's it for the day. You guys can just continue working. We'll use part of this